Hello and welcome to Partially Redacted. I'm your host, Sean Falconer, and today I'm joined by Eric Flaningam, researcher at Felicis Ventures, and we'll be discussing the history and market overview of data warehouses. Eric, welcome to the show.
Yeah, thanks, Sean. Happy to be here.
Yeah, it's great to have you here. I'm excited. I know you wrote a fantastic article that we'll get into, but let's start off with an introduction. Who are you? What do you do?
Sure. Yeah, so I'm an investor. I invest across public and private markets. I'm the author of Generative Value, which is a technology-focused investment newsletter, which is how we met. And then I'm a researcher at Felicis Ventures. So I spend my time studying early stage companies, studying industries that they compete in, and generally trying to figure out what the future of technology looks like. And then a big part of that, I've studied the data space quite a bit, which is how I wrote the data warehouse article, and it's how I came to be on the show.
Mm-hmm. Yeah, I mean, it's a pretty exciting time to be in the world of data. I would think in investment as well, because when you start to think about like what is the future of the space, it's like probably impossible to predict in any fashion right now, because I've switched from asking people where they think things are going to be in 5 years, because it's like, what do you think is going to be in 5 months is like a more realistic question at this point. So like, how do you sort of try to keep up on the market and everything that's coming out? That's like a full-time job in itself.
Yeah, it is a full-time job. I think it really comes down to like narrowing down the variables to look at. And the nice thing in the data space is like, yeah, it changes rapidly, but we also have a 40-year history of like a few companies leading in the space. Oracle, I think they invented the first SQL database, and they still have the highest market share across databases. So it's like there are new databases coming out every week. There's like analytical databases always getting $100 million rounds, but like we still have this history, this 40-year history of like deep moats in the space. And so I think it makes it a little easier to keep on top of when like, sure, there's new technologies, but there's also a lot of sustaining ones too.
Yeah, that's true. I mean, it's kind of crazy actually when you kind of forget about the beast that Oracle is. Unless you were there, like if you were building systems back in the late 90s, early 2000s, like everything was Oracle. But the thing is, like all that stuff that they sold back then is still like running those systems today. And they've also, over time adapted to the cloud, and they still have a huge market share. And they invented a lot of the technology that we sort of take for granted today. Actually, our CISO at Skyflow was one of the pioneers of data security at Oracle, 20 years ago. And he has over like 50 patents in database encryption. Like they invented all the stuff that we basically use today, which is crazy.
Yeah, it is. It is crazy. And like you look at the cloud revolutions that in the database space has been around for, a decade now, and they're just now releasing like support for Oracle database on other clouds. And it's like they still didn't have people migrate off a decade and a half into the cloud movement. It's like the moats in enterprise data are unbelievable. Once you're in a company, it's like you aren't going to move a customer facing application off that database. It's just too risky.
Yeah, it's risky, expensive, hard to do without zero downtime. All this kind of stuff gets really, really hard, like complicated. And it's like, what is the switching cost? Is it worth our time to do this?
Exactly.
Yeah. So I want to get into your article that kind of inspired this conversation, which was a primer on data warehouses. So first of all, like, what led you to writing that article in the first place?
Yeah, for sure. And if you read my stuff, you know that I study a lot of industries. And I think the thing that appeals to me, one, I initially got interested in the data space because like you hear a lot about this data and AI relationship. And I think I really thrive in like diving into the ground truth of what's actually happening there. So that got me interested in the space. Then the fact that there's public and private companies to invest in, like I study across both. And so when there's a space where there's like very large public companies and very large private companies, that gets me excited.
Mm-hmm. And then in terms of the focus on warehouses, like why would you say that that's like an important topic for audiences today? Because, if you look at, we've touched on this a little bit, like the idea of a SQL database goes back like to the late 1970s. It's been around for 50 years. And the concept of a warehouse has also been around for quite a long time. Yet it's still something that in some ways is like, it's old, but it's also, new again. I guess like, why do you think that the warehouse has stayed so relevant?
Well, I think the core value proposition of the data warehouse is incredible, right? It's like you can centralize all of a company's data, you can get insights from that data, and then you can centralize your security and your governance, your compliance on that data. So the value proposition that we're working towards is unbelievably valuable for companies. And the interesting thing about the technology is like the technology is always trying to keep up with that vision. The data itself changes so rapidly with variety and scale that the technology is almost just trying to keep up with that pace of change of data.
Mhm. Yeah, I think one of the things too that's you know, when you think about like the warehouse in comparison to something like a product or application transactional database is when we think about transactional databases for an application stack, it's all about locking down access to that data because really the only thing that needs access is probably the application in some fashion. But a warehouse is a lot more about like, hey, like we need to give certain teams access. And it's about opening access, consolidating data, like you said, in order to be able to do all this types of business analysis that we're probably not going to do at the transactional layer and aggregate multiple sources of data down into a place where we can essentially understand our business better and unlock new potential.
Yeah, exactly. I think you're better positioned to talk about the security of the data warehouse than I am.
Yeah. Well, I guess like I think just to kind of ground the conversation in your article, you give a definition of a data warehouse. Maybe we start there. Like, can you explain the definition and how does it compare to other types of data storage that people might be familiar with?
Yeah. Well, at the core level, it's what I went back to, like a centralized repository for a company's data that you can then centralize security, compliance, and governance and get analytics on that data. Traditionally, that has meant business intelligence for structured data. And then the alternative to that would be the data lake, at least in the cloud era, which is typically storing unstructured data and an incredible amount of data. I think the last Snowflake earnings call, they said something to 100, 200x the amount of data in data warehouses or in data lakes. So that's typically like the comparison there. And then over the last maybe 2 to 3 years, you've seen the vision for the data lakehouse, heavily marketed by Databricks, come out and actually gain a lot of traction, which is a pretty incredible story in and of itself. And so that's kind of like the structure. It's typically the data warehouse was structured business intelligence, data lake, it's just raw data. Data lakehouse combines the functionalities of both. But over the last, let's say, 2 years, the large data companies have all moved towards data platforms. So when you talk about when they talk about the vision for their products, it's never just structured data. It's not business intelligence. It's centralizing all of the company's data and then running analytics on all of that data. So when I think about the data warehouse, it's really a piece of that puzzle. And maybe 5 or 10 years from now, we won't even mention data warehouse except as a piece of history, but the fundamental technology will still be there.
Yeah, I mean, I think if you look at sort of like Snowflake's origin, a big part of their innovation originally was the separation of compute and storage for the warehouse and moving that to a cloud first infrastructure. And it solved a lot of scalability problems, both on compute and storage that companies were facing. But over time, they've tried to, position themselves as much more than a warehouse, as essentially like a data cloud platform that can serve the needs of both structured and unstructured data. And I think if you look at something like Databricks, they kind of started with unstructured data, and then now they're also kind of moving more to include features that are maybe traditionally part of a warehouse, and you're getting this consolidation effect because partly these companies probably want to like own all the data in some fashion, but also there's been a number of technologies I think that have come about that also help like bridge the gap between those two worlds of unstructured and structured data.
Yeah, absolutely. And it is interesting with the Databricks and Snowflake comparison because their narratives have been tied for so long now, but really it's just recently that we've seen a lot of product overlap with Databricks SQL and then Snowflake's Cortex platform, really. And it's just like that's really over the last year or two, but their narratives have been tied for, you probably know better than I do, but it's seemingly 5 to 10 years now.
Yeah, and there's been innovation, I think, in the open source world too, with like open formats like iceberg tables and stuff like that have helped like bridge the gap, and also storage on like blob storage on mediums like S3 has gotten so cheap, so reliable, and way faster, way more efficient that you can actually start to run fairly efficient like query operations directly off of S3, which then make the sort of lakehouse architecture a lot more attractive than maybe what was historically there for people.
Yeah, exactly. And if you need evidence of the importance of iceberg and open tables, you can look at the tabular acquisition of 1.8 or $2 billion, depending on the source. For I don't know when they were founded, maybe 2 years ago. I don't know how much revenue they had, but it certainly is a hefty multiple. And the initial bid, I think the one of the articles came out and said Snowflake initially came in with a bid of like 300 million. Then maybe Confluent came in at 600 million, ends up at 2 billion. So certainly, it's certainly an interesting battleground for them.
Yeah, absolutely. Yeah, and then there's, I mean, maybe we'll touch on it later, but there's a whole area of streaming data where like Confluent and other people, Red Panda and stuff like that, are starting to play as well. But going back to warehouse, I do want to kind of look a little bit at the history. There's been a long history with warehouses. Like, can you highlight some of the major milestones that have come along with the development of the warehouse?
Yeah, definitely. I'll try not to ramble, so cut me off if I do. But I think we can break down the history of the data warehouse into maybe three segments. The early years of the SQL database, the rise of application-based hardware in the mid 90s, late 90s, and then the rise of the cloud. So the early SQL database years, SQL database was being invented. People were figuring out use cases, and the end of that story is basically like these databases were getting overran with transactional requests and analytical requests. And some really smart people saw the need to separate those and build out the analytical database or the data warehouse. And then what happened with that is like that was so heavily used again, is that it was too heavy for one company to have all of their data workloads on one analytical database. They split them out into data marts. As you can imagine, when you're managing 10 or 20 data marts in a company, that also the management overhead gets really high on that. So then as these hardware modules came about, bundling compute and storage to make it easier to set them up, which kind of prefaces 20 years later for Snowflake to decouple that. And then the rise of the cloud, really, when you look at the history of softwares, as monumental of any technology that's ever come about. And so you had kind of these three trends driving this importance of the database in the early 2000s. So it's the internet with the rise of unstructured data. It's mobile, needing more applications and the ability to access those applications. Then you have the cloud, which provides a fundamentally disruptive business model to build those applications. And from that enabled the modern data stack, the Databricks, the Snowflake, to create these products over the last, let's say 10 to 15 years.
Mm-hmm. And do you think now, like as especially, there's been such a focus in the last couple of years on what we call like unstructured data, in part because of the growth and interest in LLMs and other forms of generative AI, and then also the technologies around things like the lakehouse getting better. That this transformation has changed the way that maybe traditionally data engineers, like the skill set that they need or the types of tools and technologies they need to ramp up with. Does it change sort of the nature of that job, do you think?
It certainly seems that it will over the next 5 years. I think if you talk to most data engineers, that they're probably not seeing a lot of that yet. Certainly, if you're building out some advanced, unstructured data AI applications, you will. But I think the reality of a data engineer's world hasn't fundamentally changed yet. Now, I certainly think probably over the next 5 to 10 years, it will. But I'm also hesitant to say that because it's easy to throw out these data points that 90% of data is unstructured. And I think that probably is a divide to the reality of a data engineer's world. So I try not to hype up these trends before they're ready, but I think it certainly seems like we're at an inflection point there.
Mm-hmm. Yeah, in terms of like the effort involved with working with the unstructured data too, like historically, there's still always like a mapping process to essentially add sort of structure to it. Like that's the whole point of even these like open formats, that you're basically attributing metadata to the unstructured data. So there's a lot of like manual work to map that into something that becomes queryable. But I guess with some of the Gen AI technology, maybe that some of that workload goes away, or you can automate it to some fashion.
I certainly think that we will rely more on the tools. I think fundamentally work with unstructured data is significantly more complex, or at least we don't have the skill set. I mean, SQL has been around for so long that it's like almost in every engineering school, every coding school, it's like the first class you take is like working with SQL. And so it's like working with unstructured data is fundamentally different. And so I certainly think that, yeah, we'll rely more on the tooling, at least at first, to abstract away some of that manual workflow you alluded to.
Yeah, I mean, I think every time someone tries to kill SQL, it like it comes back. Like even the NoSQL movement from like 15 years ago that MongoDB originally pioneered, like MongoDB, like now like all sort of what quote unquote SQL databases, they all support SQL at this point. And even BigQuery, when it first came out to the public, supported like a domain specific language that Google had created. And then it didn't get adoption because if you're an analyst, you're like, well, I don't want to go and learn Google's domain specific language, but I've been working in SQL for 20 years. So I think it's like hard to get away from the world of SQL.
Exactly. You can look at the two unicorns, Germio and Starburst, who were built around this SQL query engine, in large part querying semi-structured and unstructured data.
Mm-hmm. Yeah, I think Starburst is interesting, or well, like Trino that or Presto, whatever you want to call it, that came out of like Meta, is interesting paradigm because they're sort of taking a different approach. Like with warehouses or even like the lakehouse architecture, it's all about like, hey, let's consolidate our data down into one place and then keep compute close to the data, and magic ensues basically. And that, whereas the Starburst approach is like keep your data in all these places that already exist, and we'll essentially detach the query engine from the storage and be able to run queries across all those different data sources and aggregate it. I'm kind of curious, like from your perspective, like do you think that that is like does that just serve a different need, or is that potentially something that like consolidation is just not realistic for everybody, and they're going to need to be able to do sort of more of this like orchestrated query federation?
Yeah, I think my personal opinion, I think we've seen waves of consolidation and deconsolidation in the industry.
Mm-hmm.
But my opinion is that the control plane for data does get abstracted up to the data catalog layer. And so with that, you can have the data anywhere you want. You can have it where it's most optimally used, as long as you have the control of the metadata of this data catalog, the open table catalog layers, then you
Right.
can control your data. And so I think my personal opinion is that that's where we'll move.
Mm-hmm.
And so I think this federated querying is something that's appealing to me.
Yeah, and I guess even if you look at, I think some of the stuff that's happening in the like the juggernauts of the lakehouse warehouse world of like Snowflake and Databricks, they're also kind of moving in that direction too. Because I think part of it is that's just how companies want to start to operate. They want to be able to essentially not be vendor locked in terms of where the data sits, and then the vendors themselves become a lot more about compute and their ability to connect into all these different data systems and then aggregate.
100%. And if you dive into like the details of that tabular acquisition, there's this timeline that came about where both Snowflake and Databricks were bidding on this deal, and presumably Snowflake finds out they aren't going to win the deal. Then they release their open source Polaris catalog
Yeah.
the day after the tabular acquisition, or the day before the tabular acquisition gets announced, and then a week later, Databricks open sources their Unity catalog. And so you see like this battlefield just on these open source data catalogs, which presumably generate very little revenue for these companies. And it's like when you see that much action from these juggernauts in one specific area, like where there's smoke, there's fire.
Mm-hmm. Yeah, absolutely. I mean, yeah, I wonder what the product scramble was around that when they knew it's like, okay, well, let's divert all resources to building something competitive.
Yeah, it must have been an interesting time at both those companies.
Yeah, absolutely. I mean, so in terms of you know challenges around using some of these technologies, like what are some of the challenges that people run into when they're actually implementing and also maintaining a warehouse?
I think most of the challenges stem from the divide between the vision for what these products can be and actually implementing those products. In reality, most enterprises have data, one dating back maybe 20 to 50 years, and a meaningful percentage of that data, they don't know where it is. It could be stored in unstructured data in emails. It could be on the IT guy's Excel sheets on his local laptop. And like, I don't say that facetiously, because that's actually like most enterprises probably have important data on their IT guy's laptop. And so like actually navigating this complexity of data over a 20 to 50 year period. And the idea of centralizing data is really good in theory, but in practice, actually centralizing all your data in one place is a horrible task. It's so hard. And then once you have that, actually having the skills to manage to have all of this data and say these are the exact data points we want to pull out, these are the insights we want to have. It's very hard both to manage that data, to get it in one place, and then to actually make use of that data.
Yeah, and once you've actually, so there's the challenge around just like finding and consolidating the data, and then once you've actually done sort of the hard work around that, like what are some of the challenges with just like maintaining that infrastructure? Is it that every time you add a new data source, you have to think about, okay, well now we need to like write this down into our warehouse, and then what's that going to look like from like a schema perspective, and how do we control access and all this sort of stuff?
Yeah, exactly. It's exactly what you described there. Having the governance in place to know exactly how you manage new data sources. And then you also have this balance of like, you've got to report on budget every month or every quarter. And so if data warehousing costs are flying up, then upper management may say like, why are we spending so much on data warehouse? Like, what's the value here? And if you can't articulate that, then maybe you have to go back to storing some data in the data lake. So it's exactly what you said. It's having the governance in place to know what to do with data, keeping compliant on that data, and then there's inevitably some political, not struggles, but some political considerations too.
Yeah, I think cost is something that I see, especially with like the change in the market in the last couple of years, is this place where there's more and more concern. And even if you look at some of the talks at some, the Databricks or Snowflake events over the last couple of years, there's a lot more talks focused on sort of like cost optimization. I even think both vendors have released their own software or like part of their platform ways of like giving you better visibility into costs and stuff, probably because of they don't want to lose customers because of cost concerns. But like, what are some of the ways that teams think about like justifying the cost of using these technologies?
The easiest way is to have very clear analytical reporting that's driving typically cost cutting or revenue generation. So if you are managing your sales portion of your data warehouse and you can very clearly tie, these are the geographies that are doing better, here's the product mix, here's where our high margin products are doing better than our lower margin products, and saying like, this is where we do invest our resources. And you can tie that and say, we're investing our resources here, we're driving management decisions, and then we're seeing a return on that investment. It's very easy to quantify that. If you can't quantify it, it's hard to justify spending that much on a data warehouse.
Mm-hmm. Yeah, absolutely. In terms of things that are going on in the space, like we touched on some of the future trends. I think there's a lot of momentum around like the open formats and kind of turning some of these things mostly into like a compute query engine, as well as like a way to interconnect different data sources. But what are some of the other innovations or future trends that you've seen that you're excited about?
I think the biggest one is this idea of custom AI. And so I don't just say AI to throw it in AI, but actually when you look at the data management platforms, if you consolidate all the data and you manage the data in one place, you then have a really cool opportunity to use some of these innovations that are happening in analytics to then get analytics in a new manner that's custom to the data you have in your enterprise. And that's pretty powerful. And if you can do that, Databricks and Snowflake, I think both made acquisitions, but maybe just Databricks, in this conversational analytics realm, where you use LLMs to be the interface and you say, I want the exact like sales example we were using. I want insights into where our highest margin products are doing by geography. And then it maybe takes a few seconds now or 10 or 20 seconds now, but that will come down over time and you get insights right away just from conversational intelligence. And it's like, that's an exciting trend and the technology isn't quite there yet, but I think we'll see it in short order. Maybe within the next year, we'll see production grade versions of that technology. And that's pretty exciting. It's not just we're working to consolidate and to centralize data just to do it. It's like now we're actually going to see an increase in analytics from that.
Do you see some of the, in terms of like the innovation that's happening with large language models and being able to analyze, unstructured data as the really like the breakthrough that's required in order to unlock access to unstructured data? Like you mentioned this, statistic that I've heard as well, is like 90% of the world's data is unstructured. It's mostly been like locked up essentially for the last 40 years. People are just sitting on this like mountain of unstructured data and they don't really know what to do with it. Is AI really the key breakthrough to being able to start to unlock some of that stuff?
I hope so. Theoretically, I'm hesitant to use AI as the solve all, but it certainly seems like a use case that's reasonable for AI to accomplish. I think that the hard part will be understanding how to actually get value out of that, because most of that unstructured data is, let's say emails in an enterprise. Like for the most part, that's useless to scan through 30 years worth of emails. For the most part, that's not that valuable. But I certainly think that it's a use case that can make sense for AI, LLMs.
Yeah, I mean, I would be pretty excited if I could search my email more effectively than I can now. Because email search is like still terrible. so maybe there's a startup in there.
Yeah, for sure.
What about, have you looked or seen any of the work around being able to essentially convert sort of natural language into queries that you can actually run against data stores?
Yeah, I mean, I think I forget the name of the startup, but Databricks made an acquisition there that I alluded to. It's an area that Databricks is talking about a lot. Like this is their vision to be the data intelligence platform. So it's going past just storing data. And I think there's a lot of smoke around that. There's a lot of attention being given to that, and I think that generally leads to innovations. So I don't have answers to the specific like technologies. I've seen demos of startups doing it, and I think we'll be there in short order. And I'm excited for it. It's going to be highly valuable.
Yeah, I think there's definitely like a lot of complexity with being able to pull that off. But if you could, you really start to democratize access to data. Whereas, previously it's mostly been only available to someone with at least the technical skills to know how to query it. And then if you can democratize access, then suddenly your sort of speed of learning as a company can really increase.
Exactly.
I want to touch on a couple other sort of trends in data that maybe are a little bit outside the warehousing. Have you seen sort of all the buzz that's going on around like all you need is Postgres?
Yeah, I love the Postgres movement. I think it's so funny, like the cult of Postgres that is rising, and you see it all the time. Of like when you'll see like a Snowflake post somewhere, and then there's like inevitably comments like you can do all this with Postgres, and even like vector databases get all this hype, and PG Vector has come out, and I think that's getting a lot of adoption. It's not inflecting wildly on GitHub stars, but it's getting a lot of adoption.
Mm-hmm.
I'm here for it. I think it's almost it's almost like not even the interesting part of the conversation to me because it's so clearly getting adoption, so clearly has this developer love. I think the interesting thing is saying, what does that do to the business models we see? And open source, in data and AI right now are maybe the two highest areas with open source adoption. And that's a brutal competitor to go against. It's really hard to monetize open source one. And if you've already monetized closed source, it's very hard to compete against open source.
Yeah. Yeah, I mean, I think the Postgres movement is interesting as well. Like, I mean, there's certain things that like Postgres, besides being a well-made open source database, it has ways of building extensions to it. So even if you want to do something that's like custom, you can do a lot of custom work like natively within Postgres. And this past week, I was actually at a AWS meetup where a senior staff engineer from Figma was speaking about their work over the last couple of years to scale their database systems. But until 2020, all of Figma was running on a single Postgres instance on RDS on the Amazon Web Services, which is like crazy to think about. Now they've had to put in horizontal sharding and kind of like the normal things that you start to do when you hit certain scale, but they got 7-8 years of scale at Figma from a single Postgres database, which is insane.
It's insane. And then if you see that and you're a startup and you may say like, why am I going to spend, I was going to use Oracle as an example. There's not a lot of startups use an Oracle database, but the example would be like an enterprise. Why would you pay the millions of dollars it's going to take to pay Oracle when you can do it for borderline free on Postgres? I mean, you have to pay for hosting and like that costs money, but it's much lower than paying for a managed service.
Mm-hmm. Yeah. And I think once you've reached the point where you do need to do sort of more advanced distributed database type work, like horizontal sharding, or maybe even look at, maybe you put in some sort of, SQL database, DynamoDB that's built for distributed systems. Well, that's a pretty high quality problem to reach as a startup. You've reached the data scale problem of like, oh, well, we need to hire some people to come in here and like scale our infrastructure. That's a luxury that you generally don't have on, day one.
Yeah, for sure. And knowing the VC ecosystem, if you are at that point where you can do that, you'll certainly have enough funding right now to get that to do it.
Mm-hmm. Well, as we start to wrap up, is there anything else you'd like to share?
No, I mean, I think I would say like it's a really interesting time in the data space, and the competitive dynamics are getting increasingly hazy for everyone involved. There's a lot of startups in the space. There have been a lot of successful startups in the space over the last decade. But with the rise of open source, with this consolidation of platforms, it makes it very hard to build sustaining business models at every level of the stack, honestly. Whether you're an early stage startup, growth stage startup, whether you're Databricks or Snowflake. I mean, you're competing against Google and Amazon and Microsoft, and even like Snowflake and Databricks are two of the most successful B2B SaaS companies ever, and it's still unclear what their competitive landscape looks like. And so I think I would say it's a hard time to be building in this space. And if you're able to navigate that, I think that's an incredible accomplishment.
Yeah, I mean, it's an interesting point you're making where like clearly there is a continual market need for data innovation. And that's why like it's like even if you just look at Postgres, like there's so many flavors. There's probably like 100 different, at least 100 different flavors, maybe 1,000 different flavors of like Postgres, and that's just Postgres. So there's always like new sort of databases and inspiration that's coming from different types of databases. But then the big question is, there's a market for it. There's a market need. There's always innovation going on, but can you build essentially a sustainable business around all this is the big question.
Yeah, exactly. And when I think about how a company generates long-term value, it comes from one, providing value to the marketplace, but then two, there has to be a delta there between what you provide to the marketplace and what your competitors provide to the marketplace. And it's hard to generate that delta right now. And then, if you have that delta between what you provide and what your competitors provide, then you can collect whatever portion of the profit you want here. But if you don't have that, if it's this small, it's hard to generate a profitable business over the long run.
Yeah, I don't know if it's quite a perfect analogy, but it's a little bit reminds me of the transformation that's happened somewhat in like programming languages and programming tools. Like there's not a programming language that is popular in any fashion today that's not open source and just freely available. And same with dev tools. But if you look 20 years ago, that wasn't necessarily the case. Like all the Microsoft tools suite was closed source. Their languages were also, for the most part, closed source. So, but they've had to adapt and change with the times, and it'd be very, very difficult to launch a company today that's like, oh, we're going to be the next, IDE that's like a public company. Like, there's just not a market that's willing to pay for that. Essentially, you have to figure out a different avenue to actually turn that into a business.
Exactly. It's what I spend a lot of my time thinking about. If open source continues to rise, does software get mostly commoditized? And in the classic commoditize your complement, the squeezing of the water balloon by Clayton Christensen, the value chain, the value flows to the cloud providers again. And the thing that makes it really hard for the pure play data companies is that where the value flows is also your biggest competitor with all of their managed open source offerings too.
Yeah, absolutely. Well, this was a really fascinating discussion. We'll have to have you back at some point. I'm sure there's another topic of conversation we can dig into. But thanks so much for doing this, Eric.
Yeah, thanks for having me, Sean.
Cheers.